Hello. In this video, we will go over solids of revolution, also known as shell method, or also known as cylindrical shell. So, uh, this is calculus 2, and we are learning solids of revolution shell method, or also known as cylindrical shell. So, in the previous video, you should have learned how to do the washer and the washer method. So, this method works either way. So you can use this method. Um, and you get the same answer. So you've learned, I think, called the disk and shell method, the disk method. So here's just another alternative. So the shell method or cylindrical shell is an alternative form of the disk and washer method. Uh, it's just another way of finding the solid of revolution by taking a bounded region and rotating around the vertical or horizontal axis. But instead of using slices that are perpendicular to the axis of revolution, we're going to use the slices that are parallel axis of revolution and create a cylinder when we rotate. So you must know how to take surface area of a cylinder. So yeah, you must know how to take the surface area of a cylinder. You will also learn when you must use the shell method versus the disk or washer method. So yeah, let's briefly talk about shell method or cylindrical shells. So uh, let's pretend you have this graph looks like an upside down square root. So on the disk method, uh, you're taking what is it? You're taking disk, right? And so you're taking you're making small disk and the so here's an example of a disk. You would take the volume equals pi and then from a to b in r squared d of x. So with disk and washer method, you're creating disk, and with the shell method, you're creating cylinder. Okay, so keep in mind this is your radius, and then notice that you don't have any gaps. So when you were doing the washer method, you did have a little small gap. So that's kind of like the difference. So let me repeat that again. With disk and washer method, you're creating a disk, and with the shell method, you're creating a cylinder. And with washer method, you have a little gap or a small r. So another keynote for shell methods. So with shell methods, you are going to revolve that rectangular slice and is perpendicular to the axis of revolution. It generates this ring or disk. So let me write that down. Okay. So yeah, shell method. So yeah, with shell method, you're revolving around that rectangular slice and is perpendicular to the axis of revolution. It creates this ring or disk. Okay. So, okay, yeah. So it's just something I repeat. With dot disk and washer method, you're creating a disk, and with shell method, you're creating a cylinder. So let's kind of review what we were doing with the washer method. So that was the disk method, right? You're creating a small disk. And with the washer method, so with the washer method, you have a little gap or a small r, right? So you have this little, you're still making a disk, but this time you have this little small r, and then this is your big R. So what we have to do with the washer method, it's v equals pi from integrals a to b of big R squared minus r squared d of x. So also note for the washer, you have this axis of revolution, and the shaded area is not exactly flush against the line. So there is a little hole or gap pieces being removed. So you have this little hole. So you're basically in the washer method, you're creating this that has a hole, right? If that makes sense. Yeah. So dish method, you have no hole. Washer method, you have a hole. Okay. So that should have been review. With the dish slash washer, disk and washer, rectangular slice is always perpendicular to the axis of revolution. Okay, that was review. Now let's talk about shell method. So shell methods, you create rectangular slices and are parallel to the axis of revolution. So with shell method, instead of creating disk, you're creating a cylinder. So here's an example of a shell method. Here's this graphic here looks like some kind of square root of x. And then you have this vertical line right here. And it has a horizontal axis of rotation. So, and then this is big R. I mean, this R of x represents a radius. So this R of x represents a radius. And here's a typical formula. V equals 2 pi from c to d of R of h, R of y times h of y dy. So why is it in terms of y? Well, because we are revolving on the horizontal axis of rotation, uh, right? You're revolving around here. That means everything has to be terms of y because you're going parallel, right? So yeah, so this time with the shell method, you have a radius, and then you have this distance here. They call it h of x. Okay, so you have a radius times this distance. So it's a horizontal distance because it says horizontal axis of rotation. So that means everything has to be in terms of dy. And if it says revolving around the vertical axis of rotation, so on the y-axis, you're it's the same idea. Volume equals 2 pi, but everything will be terms of x or d of x, and it's still the radius times the this vertical distance. So this distance, h of x. Okay? So I think that's a lot easier than the distance shell method. So yeah, v equals 2 pi from a to b, and then the radius times the distance of the this vertical distance, right? This distance. So like we said, we are making cylinders. So imagine taking a piece of paper and folding it into a cylinder. You can find the surface area of that cylinder. So r, small r equals the radius, which is the displacement from axis of rotation and some x or y slice. H is the height or the length of the slice, right? So this is the H, and this is the R. So it looks a bit confusing, but it's really not. And so yeah, you're creating a cylinder, and yeah, and then what do we know about cylinder? We could take the surface area. So the surface area of a cylinder is volume equals 2 pi times r times h times the w, which is representing the width or thickness. So yeah, this small r is their average radius. This is your h, and w is the width slash thickness. So in shell method, you're really just unfolding a cylinder and finding the area of the surface area. Then you can grade it. Then you can integrate that's going to create thickness or volume. Then you can calculate using calculus. Okay, let's do an example, and I recommend getting some kind of graphing calculator or a Desmo to really see what's happening. So example one says, use shell method to find the volume of the solid revolution. We have the line y equals square root of x. I know what that looks like. X equals 0. That's, yeah, a vertical line. X equals 4. I know what that looks like. And y equals 0. And it's revolving around the x-axis. So you can put all those equations in Desmos if you like. I kind of have an idea. So let me first draw my image, my graph, the best I can. The better, the better. I mean, the more detailed, the better. Here's your x, and here's your y. So what does y square root of x look like? It looks like the square root graph, right? What does x equals 0? That looks like this. What does x equals 4 look like? Let's pretend this is not a scale, but let's pretend this is 4 right here. And it says we are revolving about the x-axis. So here's the x-axis, we're revolving around here. Since we want to make our slice parallel, we want to make, so when you're doing the shell method, you always want to make your slice parallel to the axis of revolution. So we want to make our slice parallel to the axis of revolution. So in this case, our slice is perpendicular to the y-axis. So our slice is perpendicular to y-axis. Okay, so if that's the case, that means, okay, so we have our graph. We have x equals 4, y equals square root of 4, x equals 0, and then y equals 0. Y equals 0 would look something like this. And we are revolving around the x-axis, so here's the x-axis. So our equation is going to be volume equals 2 pi. And then since we have to be parallel to the axis of revolution, our boundaries is going to be from c to d. And then r times the height, the radius times so our little rectangular slice would look like this. So why are we making it horizontal like this? Because it says our slice has to be perpendicular to the y-axis. So here's the y-axis. So it's revolved about the x-axis, and that means our slice has to be our slice is perpendicular to the y-axis here. Here's the y-axis. Remember, perpendicular makes like that, yeah, 180. So this is perpendicular to the y-axis. And we got to find this distance. This is our h. So what would be our, and then if it's if it's revolving about the x-axis, that means everything has to be in terms of y, dy. So it's it's a little tricky. It says why is this in terms of dy since we are going parallel to the x-axis, right? So everything has to be in terms of y. So let's find our c and d, our boundaries. So we have y equals 0 and y equals square root of x. And then one of our x value was 0. So yeah, if you plug in 0 into this function, this is square root of 0, which is 0. I think our c is 0. And then our other x value was given as 4. So that's square root of 4, which is 2. So volume equals 2 pi from the integral of c to d. So my lower boundary is 2. My lower boundary is 0, and my upper boundary is 2. So remember, we're in terms of y. Everything has to be in terms of y. Okay, and then the r. So how do you find the radius? So the radius is this distance from the slice to so yeah, the radius is going to be the distance from the slice to the axis of revolution. Okay, so if you look, this would be our r. So our r is the distance from the slice to the axis of a revolution. So this distance right here is our small r. So what is that going to be? So it's going to be y minus minus this graph 0. So it's y. So my small r is going to be y minus x equals 0. So 0. So that's my radius. And then how do you find the height? So the height is going to be expressed. This is our height right here. So how do you find that distance? Well, it's going to be the top. Since we're going revolving around the x-axis, it's going to be the top minus the bottom, right? So what is our top function and what is our bottom? The top is, it looks like it's going to be x equals 4. So it's going to be 4 minus the bottom. And what's the bottom? It's the square root graph. But because it has to be in terms of y, how do we do that? So the bottom is, so the top is this line, and then the bottom is the square root. So, but be careful, we have to be in terms of y. So I have to kind of like solve for x. So I'm going to square both sides. You get y squared equals x. So it's going to be 4 minus y squared because we have to put it everything in terms of y. Okay, so let's just do, so my radius is y minus 0. It's distance r. It's basically this distance right here. And then the height is this distance, which is the top minus the bottom. So the top is 4 minus y squared. right? This is the top. The square root is the bottom, but we had to put it in terms of y. I had to solve for x by squaring both sides. And then it's dy. Okay, so that's how we set it up. Now we just got to clean it up and integrate. So this is easy. What's y minus 0? Y times 4 minus y squared dy. So v equals 2 pi, 0 to 2. And then FOIL out this y. So y times 4 is 4y. Y times negative y squared is negative y cubed dy. And then how do you take the integral of 4y? That's easy. That is 4y squared over 2 minus, what's the integral of y cubed? That is y4 over 4. And then because we took out a 2 pi, clean that up. Okay, let's see. You could do your boundaries now, and then distribute the 2 pi. That's what I'm going to do. So do the uppers. Wait, 4 over 2. That's 2 pi squared. So plug in your upper minus lower. So it's 2 times 2 squared minus 2 to the fourth over 4. And then this one's easy. It's just replace that. That's just minus 0. So you get v equals 2 pi. And 2 squared is 4 times 2 is 8 minus 2 squared, 2 to the fourth over 4 becomes 4. So it's going to be v equals 2 pi. 8 minus 4 is 4, which is 8 pi. So my volume is 8 pi because I took out the 2 pi, right? Okay, let's move on to example 2. Example 2, we have y equals square root of x, and x equals 0, and x equals 4, and y equals 0. This time we're revolving around the y-axis, so it's just exactly like example 1, right? Yeah, it's exactly like example 1, but this time we're revolving around about the y-axis. So our slice is parallel on the y-axis, and the radius is between the axis of revolution and slice. All right, so let me draw the image again. So this is y equals square root of x, and then x equals 4 could be like here. Right, this is not a scale. And then this is what we focus on. And since we're revolving around the y-axis, here's the y-axis, here's the x. Revolving around here, that means everything has to be in terms of x. So our slice has to be perpendicular to whatever axis we have. So here's the y-axis, our slice is perpendicular to that. So it's going to be this way. Our slice will be vertical. Okay, so that we got to find this height. And so yeah, let me write this out. Our slice is parallel on the y-axis. So the radius is between axis of revolution. And slice. Okay. So our equation is going to be V equals 2 pi. And then because everything has to be in terms of x, it's going to be from A to B. So like this distance. And it's going to be, let's see, 2 pi. And then it's going to be, say, radius times the height. And then in terms of x, d of x. Okay. So now we got to find the radius and then we got to find the height. So V equals 2 pi. And what would be our radius? So our radius would be this distance here. And then this is our height. So how do I find this? How do I find ours? It's going to be, in terms of x, it's going to be x, because in terms of x, so it's going to be x minus, what else? X equals, I mean, x minus x equals 0, right? Which is 0. So x minus 0, that would be my radius. And then what would be our height? Since we are parallel to the y-axis, it's going to be the top. This time it's going to be top minus bottom. So the height is top minus bottom. So it's going to be square root of x minus 0 d of x. What about our a and b, our lower bound, our lower and upper? So in terms of x, oh yeah, I believe it's already given. One of our line was x equals 0, and the other one is x equals 4. So that was given. So it's going to be from 0 to 4. Okay, so that's how you set it up. And then just clean it up. X minus 0 is just x times square root of x d of x. Now, you can clean that up a bit. What's x times square root of x? Well, you could put that everything in power x to the 1 times x to the 1/2. And when you're multiplying, you're adding. So what's 1 plus 1/2? Or 2 over 2. So that would be 3/2. Okay, so how do you take the integral of 3/2? That's easy, right? It's old power plus 1 divided by that power. So it's old power just 3/2 plus 1. In our case, it could be like 2 over 2 divided by, what's 3/2 plus 2 over 2? That would be 5/2. So you get a complex fraction as x to the 5/2 divided by 5 over 2. And if you cross multiply, this is going to be 2x to the 5/2 over 5. The volume, and don't forget we still have that 2 pi, so it's 2 pi of 2x to the 5/2 over 5. And our lower boundary is 0 and our upper boundary is 4. So if you do that, that's going to be 2 pi. And then apply the upper minus the lower. When you put that in the calculator, 4 to the 5/2 times 2 to the 5th is 64 minus 64 over 5. Minus, this is 0. So when you put it all together, you should get V equals to 128 pi over 5. Okay, so you kind of have an idea how to do this. Let's continue. Example 3 says use the shell method to find the volume of the solid of revolution. we have y equals square root of x and x equals 0, and then x equals 4, y equals 0, and then we're revolving around about the line x equals 6. Okay, this is a little bit different. We're revolving it around x equals 6. So let's draw our image. So y equals square root of x looks like this. Uh, X equals 0 is like this vertical line. X equals 4, let's pretend this is 4. And then x equals 6 is like right here. So let's pretend this is 6. And we're revolving about the line x equals 6. So it's revolving around here. Okay. Okay, so if we're revolving around x equals 6, I believe our slice will be vertical like this. And then I believe our terms will have to be in terms of dx or x. So a to b. And then what is our radius? This is our radius from this distance here to this distance there. So it's volume equals 2 pi from the integrals a to b, and then it's r times h of d of x. So the radius represent the vertical slice to the axis of revolution. So yeah, like we said before, we kind of have a problem here. We have this little gap, right? But don't worry, we can still figure it out. So volume equals 2 pi, and then our boundaries from a to b, or in terms of x. So that was kind of given. Our uh, lower boundary was x, and our upper boundary is 4. So from here to here. And then let's find our radius. So our radius is going to be this line, x equals 6. So our radius is going to be this line. We're kind of like going backwards. X equals 6 minus, in terms of x, it would be x. Right? We don't know. X is like this distance here. We don't know what that is. So we call it x because we are taking it in respect to, it has to be in terms of x. So it's going to be 6 minus x. And then what would be our height? Our height would be the top minus bottom. So the top is square root of x. Keep in mind we're taking it in respect to x. So square root of x is fine, minus the bottom, which is x equals 0. So that's minus 0. Okay, so it's going to be square root of x minus 0 in terms of x. So this is our small r, and then this is our height. So volume equals 2 pi from 0 to 4, and then kind of clean this up. 6 minus x can't really do much, so 6 minus x. Square root of x is the same thing as x to the 1/2 d of x. So v equals 2 pi from 0 to 4. And then if you FOIL out this 6 times x to the 1/2 is 6x to the 1/2. And then negative x times x to the 1 will negative x1 times x to the 1. We're multiplying or adding, so that would be minus x to the 3 halves d of x. Okay, so how do we take the integral of this? This is not too bad. You just take the integral of each term. So the integral of 6x to the 1 half is whole power plus 1. So 1 half plus 1 or 2 over 2 over what's 1 half plus 2 over 2, 3 halves. So that is going to be 6x to the 3 halves divided by 3 over 2. And when you do the algebra, you should get, I'm going to do it for you. It's going to be, when you do this, it's going to give you 4x to the 3 halves. And then what's the integral of negative x to the 3 halves? It's just old power plus 1. So old power is 3 halves plus 1 or 2 over 2 over 5 halves. And when you do that, you should get negative 2/5 x to the 5 halves. So volume equals 2 pi from 0 to 4. And this is going to be, oops, we already did that. It's going to be, we already did the integration. So it's going to be v equals 2 pi bracket. And the integral of 6x to the 1 half is 4x to the 3 halves minus the integral of negative x to the 3 halves is negative 2/5 x to the 5 halves. And then you do your upper and your lower. So do the upper, so it's 4 times 4 to the 3 halves minus 2/5 4 to the 5 halves minus, and then this is easy, when this is going to be 0 minus 0, that's 0. So this is going to be v equals 2 pi. And then if you put this in the calculator, 4 times 4 to the 3 halves should give you 32. Minus, and when you put this in the calculator, 4 to the 5 halves times 2/5 is negative 64/5. And clean this up. When you do all the work, you should get volume equals 192 pi over 5. Okay, let's do another one. Let's do the same exact one, but this time we are revolving at x equals negative 3. Example 4 is exactly the same problem. The only thing is we're revolving around the line x equals negative 3. So we have y equals square root of x equals 0, x equals 4, y equals 0, and we're revolving around x equals negative 3. So let's kind of graph it. 0, square root of x, this x equals 4 would look something like this. And you have this shaded line. And then you have this, if we're, okay, so, oh yeah, x equals negative 3. Let's pretend this is negative 3 right here. And we're revolving around that line. So what that means is, and then that means our slice will be vertical like this. And this is now our radius, and then this is our height. Now, if we're revolving around x equals negative 3, that means everything will have to be in terms of x. So we're going to set it up as v equals 2 pi from the integrals 0 to 4. Now, our radius, radius must always be positive. So it's going to be this distance, we don't know what it is, x minus this distance, which is -3. So yeah, that's something to note about. Radius is always positive. It's going to be this unknown distance x minus the vertical line -3. So that is going to be two negatives becomes a positive. So our radius is going to be x plus 3. And then our height is going to be the square root of x minus 0. So that's just going to be square root of x, or x to the 1/2 at d of x. The volume equals 2 pi from the integral of 0 to 4. And then if you FOIL this out, this is a power of 1, so x to the 1 times x1 times x to the 1/2. That's going to be x to the 3/2 plus 3 times x to the 1/2 is 3x to the 1/2 d of x. And then we can take the integral of each term. X to the 3/2 is like, it's just all power plus 1. That should give you 2x to the 5/2 over 5. And then what about the integral of 3x to the 1/2? It's just old power, 1 plus 1/2 plus 1 to the 2, which is 3/2. And that gives you 2x to the 3/2. So volume equals 2 pi. And the integral of x to the 3/2 is 2x to the 5/2 over 5 plus the integral of 3x to the 1/2. That simplifies as 2x to 3/2. And then we do the lower and the upper. Those are going to be 2 pi, and then apply the upper to where you see an exponent 4. And then minus 0, that's easy, that's 0, because if you plug in 0 here, that's 0. Okay, so that's going to be 2 pi, and then so when you put this in the calculator, 2 to the 4, 2 parentheses 4 to the 5/2 over 5 is 64 over 5. And then plus 2 times 4 to the 3/2 is 16. So when you put it all together, you get volume equals 288 pi over 5. Okay, let's do a few more examples and then we'll be done. Example 5 says y equals square root of x equals 0, x equals 4, y equals 0, and then we're revolving about the line y equals -2. Okay, so yeah, we're pretty much using the same problem, but we're just revolving it differently, right? So here's y equals square root of x, and then the vertical line is x equals 4 right here. And then the line y equals -2 is way down here. So we're revolving about the line y equals -2 right here. And then if we're revolving around y equals -2, our slices will be horizontal. So here's our slice. And yeah, so this is our h. And at this distance here will be our radius. So keep in mind, we're revolving around the line y equals -2. So I believe everything will be in terms of y. So it's going to be v equals 2 pi from the integrals c to d, not a to b, radius times h in terms of y dy. Now, do we know our boundaries from? No, we only know our x equals 4 and x equals 0 and equals 4, but we don't know in terms of y, so we don't know it. We need to know this distance. I think since our 2x value is 0, so just plug in your 2x values into this and you'll be fine. So if you plug in a 0, square root of x or square root of 0 is 0. And if you plug in 4, square root of 4 is 2. So yeah, I think our lower boundary is 0 and our upper boundary will be 2. Okay, so it's going to be from 0 to 2. And then what would be my radius? Remember, radius won't always be positive. So it's going to be this unknown distance. Since we're taking an evolve y equal the line y equals -2, it'll be terms of y. So it's going to be, so we don't know what this value is. We don't know what this value, so we'll call it y, right? Minus the line y equals -2, right? Which is -2. So it's -2. And then what would be our height? So for revolving around the line y equals -2, it's going to be top minus bottom. So it looks like the top, oh, be careful. We have to put it in terms of y. We have y equals square root of x. I got to put that in terms of y, so I have to solve for x by squaring both sides. This could be y squared equals x. So what would be my top? I believe our top will be the x equals 4. So our height is going to be 4. The top is the 4 minus the square root, which in terms of y would be y squared. Okay, so that will be our height. Okay, clean this up. So it's 2 pi 0 to 2. 2 negatives becomes a positive times 4 minus y squared dy. Okay, then you're going to have to do some algebra before we integrate this. So FOIL this out. What's y times 4? 4y. What's y times negative y squared is negative y cubed. What's 2 times 4? 8. What's 2 times negative y squared is negative 2y squared dy. So it's v equals 2 pi from 0 to 2. And then I guess just clean it up by putting in order. So it's going to be negative y cubed, negative 2y squared, plus 4y, plus 8 dy. So what's the integral of negative y cubed? It is negative y whole power plus 1, so 3 plus 1 is 4 over 4. What's the integral of negative 2y squared? That is 2y, 2 plus 1 is 3 over 3. It's the integral of y1, whole power plus 1, so 1 plus 1 is 2 over 2. And the integral of 8 is 8y. Okay, so this cleans up a bit. For 4y squared over 2 is 2y squared plus 8y. And then, let's see, our upper and our lower. And then don't forget the 2 pi. Okay, so wherever you see, do the upper. So wherever you see y plug in 2, so that's going to be negative 2 to the 4th over 4 minus 2, and then 2 cubed over 3 plus 2 squared plus 8 times 2 minus, and then the lower boundary is 0. So v equals 2 pi. And then when you put this in the calculator, it gives you -4. When you put this in the calculator, it should give you -16 over 3. When you put that, that should give you +8. And then 8 times 2 is 16. V equals 2 pi. And then when you put this in the calculator, you should get 44 over 3. And when you all put it, when it's all simplified, it should give you 88 pi over 3. Okay. Okay, let's do another example. Example 6, it's like the same equation, y equals square root of x equals 0, x equals 4, y equals 0, and then we are revolving around the line, about the line y equals 3. Go ahead and draw your image. So if we're revolving around the y equals 3, that means everything has to be in terms of y. We know from previous examples that this distance 0 and then this should be 2. And then you have y equals square root of x like this. And then you have this vertical line, x equals 4 like this. Here's our shaded region. Okay, so if we're revolving around y equals 3, our, our slice will be horizontal like this. Okay, so this is our height. And then, oh, I forgot to draw y equals 3, so let's pretend this is 3 right here. Y equals 3 would be this line. And then we're revolving y equals 3 like that. So what would be our radius? Oh, we gotta set it up first. So we're revolving around y equals 3, so everything has to be in terms of y. So it's gonna be b equals 2 pi from the integral c to d, radius times height in terms of dy. So what's our c and d? That was given. We figured out from the previous problem, it's from 0 to 2. Because if you plug in your x value in here, y squared is 0, 0. And if you plug in your x value 4 into y equals square root of 4, that's 2. And then it's going to be the radius. What's our radius? Is it would be this distance. So that would be 3 minus, so remember radius is always positive, so I use +3. So radius is 3 minus uh, this unknown value, which is y, right? Because we have to be in terms of y. So it's 3 minus y. And then what's the height? If our distance is like this, that means our height is going to be top minus bottom. So what's our top? It is 4, I believe, right? The top would be 4. So if you look at this section here, the top is this vertical line, which is 4 minus the square root graph, but in terms of y, it would be y squared. dy. And then go ahead and just clean this up. 3 times 4 is 12. 3 times negative y squared is negative 3y squared. Negative y times 4 is negative 4y. Negative y times negative y is positive y cubed dy. And then just kind of clean it up, put it highest power to lowest, so y cubed, and then negative 3y squared, and then negative 4. I don't think we can combine, just put it in order. Okay. So take the integration of each term. So what's the integral of y cubed? That's y4. What's the integration of negative 3y squared? That's negative 3y cubed over 3 minus, what's the integration of negative 4y? 1. Negative 4y squared over 2. What's the integration of 12? That's 12y. That's good. And then this cancels, so you're left with negative y cubed minus 2y squared plus 12y. And then we're going from boundaries from 0 to 2. Go ahead and continue with the algebra. So upper minus lower, so that's 2 to the 4th over 4 minus 2 cubed minus 2 times 2 squared plus 12 times 2 minus, and then this is going to be 0. And when you put it all together, you should get, I think this is going to be 12. So 12 times 2 pi, your volume will be 24 pi. Okay, let's do one more. Sample 7 says, find the volume of the solid form by revolving the region about by the graphs about the axis of revolution. So we have y equals x, y equals 4x minus x squared, and we're trying to revolve the line about it, x equals 7. So these are two different equations. So we got to draw a new graph. I know this is a parabola and it looks like it's concave down. And I know this is a linear line that's going positive, right? If we're revolving around the x equals 7, everything has to be in terms of x. Okay, so let me kind of draw it a bit. So let's see here. Maybe we should find the point of intersection. I think that would be helpful. Point of intersection. So basically you set the equation to each other. And then let's get one side 0, so subtract x, subtract x. So 0 equals 4x minus 1x is 3x minus x squared. And then let's solve for x. So maybe I could take out an x. So this would be 3 minus x. And then when you solve for x, you should get x equals 0. And then when you set that to 0 and solve for x, you should get 4, right? 3 minus x equals 0. Yeah, not, yeah, it should be 3. Why did I say 4? So you're going to have, it looks like they're going to intersect at 2 points. So we found only the x coordinates. So remember, point of intersection is a coordinate. So let's find the y coordinate. Where should we put? You could put it anywhere. You could put your x coordinate here, figure out the y, or here is. I believe it's going to give you the same results. So if I plug in, yeah, if I plug in, I'll put it in here. As I think it's easier. Yeah, so I think you have a point of intersection is 0, 0, and then the other one is when you plug in x into this, it should give you 3. So 3 comma 3. If you kind of graph that, 2, 3, 2, 3. This one is 3 comma 3. And then this point is 0, 0. And then if you want to graph it nicely, this is an upside down parabola. Let's find the x-intercept real quick. So to find the x-intercept, you set y to 0. So like you can take out 1x. So x equals 0, and then x, when you solve for x, over here, this should give you x equals 4. So it should look something like this. So the parabola will look like this, concave down, goes to the 0.33, and then it has an x-intercept of 4, 0 like that. And then the linear line is easy. It goes through this y equals x goes through the origin like that. And then it has to go through 3, 3. So it should look something like this. Okay, so this is the shaded. You want to find this area right here. And then our disk is, if we're revolving around the axis, x equals 7. We're 7. It's 7. And then our slice will be would look vertical like this. Okay, so what would be our radius? It would be this distance from this distance. And then this is our height right here. Okay, so you can only do the shell method because we have this little gap. Uh, yeah, we can only use the shell method. So our equation is going to be, so you can't, yeah, you can't do the dot, disk, and washer, just only the shell. So v equals 2 pi from the integrals. If we're taking revolving around x equals 7, everything has to be in terms of x. Our boundaries will be from a to b, r times h times dx. So v equals 2 pi, and then a to b. So it's from 0 to 3, right? Because this is where the shaded area is here. So our boundary will be from 0 to 3. And then what's our radius? It's going to be the stop minus the start. So my stop is at line x equals 7 minus this. I don't know what this distance is. We'll call it x because we have to take it in terms of x. So it's going to be 7 minus x. And what would be our height? Let's see. Our height would be the top minus the bottom. So the top is what would be our top? Oh, our top would be the parabola. So it would be 4x minus x squared minus the bottom would be the linear line. So minus x. If you clean this up, this would be negative x squared. 4x minus 1x is 3x. So it's going to be 3x minus x squared dx. 0 to 3. And then if you kind of clean this up a bit, this would be 21x minus 7x squared minus 3x squared plus x cubed dx. Okay, so it's going to be 2 pi. Oh, let's just take the integral of each term. So the integral of 21x is 21x squared over 2. The integral of negative 7x squared is, oh, wait, I could have cleaned this up. What's negative 7x squared and negative 3x? That's negative 10x squared. So the integral of negative 10x squared is negative 10x cubed over 3. And then the integral of x cubed is x4 over 4. And I don't think we can reduce, so we can put our boundaries from 0 to 3. And then you have the 2 pi here. So it's volume equals 2 pi, and then apply your upper boundary minus your lower. So it's going to be 21 3 squared over 2 minus 10 3 cubed over 3 plus 3 to the fourth over 4, and then minus, when you do the lower boundary is 0. And when you put it all together, you get 2 pi. And then when you put that in the calculator, you should get 99 over 4. Or your final answer should be 99 pi over 2. So when you do the algebra, you should get 99 pi over 2. Okay, I will stop here. So this is the shell method.